in case you weren't paying attention in construct understanding, we created a new law. We had log of a base of a power, or a number, and we made it into log of that number over log of that number with a common base. We used log base 10. If you want to figure out how we did that, you can look back at the construct understanding video. But what we're going to do now is we're going to go forward using this as a pattern that we can employ. So in example 1, they want us to approximate, because it's not going to be exact, but approximate is going to be pretty close. We're not just roughly estimating here. It says log base 6 of 100. So if I've got log base 6, whoops, log base 6 of 100, and I follow this pattern, then the number that's here gets its own log on top, and I can use log base 10 because that's the one in my calculator. So I go log of 100 over log of the base, which in this case is 6. Now in my calculator, I'm going to just calculate it. So, dun, dun, dun. Gotta go log 100 over log 6. So I have my log button, 100, close bracket, divided by my log button, 6, close bracket, equals 2.5701, blah, blah, blah. Why is it approximate? Well, it's a non-repeating decimal that goes on forever, so you're just going to have to write down the closest number that you can estimate from that, or approximate. Let's go with 2.57. So we can even say 0 because, you know, there's a 0. And then it wants you to write the expression as an exponential expression. Well, that just is there to remind us what this number means. We were supposed to find 6 to the power of what equals 100. So we will write 6 to the power of 2.570 equals 100. And if we want to check to see, and that because we can't use this value, we approximated, we would actually type in 6 to the power of 2.570. And what we end up with, when we write that in, is 99.965, blah, blah, blah. So it gets rounded up using significant digits, but you can see that it is a slight approximation because it didn't actually give us 100. If we had written 6 to the power of answer, we would have gotten 100. But that's not what we wrote down here. That's not what we approximated. Right. Want to try that again? Let's try that again with a different one. This time I'm going to use log base 3 of 2. So that's going to become log over log. This is the ones we use in our calculator. And the big number out here, don't care if it's bigger or smaller than the number, it's just the big number, like big font, goes there. The base goes on the bottom, base on the bottom. And now we have our equation. We use our calculator. And we write in, we've got log 2 over log 3. So log 2, close bracket, divided by log 3, close bracket, equals 0.6309. Let's go with that because it's 0.9. Now, to write that as an exponent, I remember that 3 is my base, that my answer is actually the exponent, and the big number is the answer when I raise 3 to that power. And again, I can put that in my calculator. Got my 3 to the power of 0.631 because I approximated it, equals, well, look at that, 2.000. Yeah, it's pretty much 2. Not entirely, approximately 2.